Hi class, welcome to another lesson. Today what we're on is we're on 2.6, which is graphing piecewise functions. Now what piecewise functions are, class, is it's basically just multiple lines that have restrictions on them to make one function. So when we're doing this, I want you to remember a couple things. First of all, pay very close attention to the notation of these. The notation can be a little bit tricky, but once you understand that, it really isn't very difficult after that. One other thing I want to review with you before we get started is something that you learned back in elementary school. If you learned something like x is greater than 4, maybe you did this on a number line, and here's 0, 1, 2, 3, 4, and what you had here is then you shaded a line that just kind of looks like this. And then you had something that goes right here, whether it be an open circle or a closed circle. If it is greater than or less than, you're going to use an open circle. If it's greater than or equal to or less than and equal to, so if x is greater than or equal to, then you're going to have a closed circle there. So if it's greater than or less than, you're going to use an open circle. If it is greater than or equal to or less than or equal to, you're going to use a closed circle. So those are just two reminders as we go on to do these four problems in our notes for today. We're starting with number 2. Number 2, it says graph each piecewise function, identify the domain and the range. We're going to be doing this part tomorrow, identifying the domain and the range, so don't worry about that for this lesson. All we're going to worry about is the graphs. Now, here's the notation that I was telling you that was kind of tricky. F of x equals x, and f of x equals 2. We're not going to worry about this if part right now. We're going to do that at the end. Class, what I want you to do right now is make sure that you have a pencil out for this lesson with a good eraser. If you're using a pen, pause the video, go find a pencil to use, because you have to have a pencil with a good eraser on this lesson, because you will be erasing quite a bit. Alright, f of x. When you see f of x, most oftentimes you can substitute a y in for that. F of x just means a function of x, which oftentimes we call that variable y. So we have two different lines here. We have y equaling x and y equaling 2. Y equaling x and y equaling 2. So class, all we're going to do one at a time, we're going to graph those functions, and then we're going to put the restrictions on them. The restrictions is the if part. So we have our first line of y equals x. Some things that I do, y equals mx plus b. Y equals 1x plus 0. So my y-intercept is 0, and my slope is a slope of 1 over 1. Rise of 1, run of 1. Now class, for these type of graphs, I kind of told you the past couple days that you could just draw a straight line now using a straight edge. However, in this lesson, what I want you to do, it's very important that we continue this slope the whole way through. So what I want you to do is I just want you to use that same slope and use up all the graph paper that you're given. What I mean by that is the slope is 1 over 1. So I'm going to continue going up 1 over 1, up 1 over 1, up 1 over 1, for as far as I can go. Same thing, I'm going to go as far left as I can go, so it's going to be down 1, or sorry, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, and so on and so forth for all the graph paper that I'm given. Now, class, I want you to connect these dots. It's still good to use a straight edge with your dots so close together. You can probably eyeball it good enough. It's never a bad idea to use a straight edge, though. So you just graph this line, f of x equals x, or y equals x. Now, class, what I want you to notice is I want you to notice this restriction. The restriction says y equals x if x is less than 0. So your x-axis is this horizontal axis. Now, all this line wants is all of the x's that are less than 0. X is less than 0, so it wants a -1, -2, -3, -4, -5, -6. All those are less than 0. It doesn't want any of the ones that are greater than 0. So we're just going to get rid of the ones that are greater than 0. And this is what I mean, you're going to want an eraser for this one. Here is 0. And you want everything less than 0. X is less than 0. So you don't want X when it's 1. You don't want X when it's 2, or 3, or 4, or 5, or 6, or anything bigger than 0 you do not want. You only want it when it's less than 0. So here is your function for f of x equals x if x is less than 0. A -1 is less than 0, -2, -3, -4, -5. All of those are less than 0, so you want all of those on your graph paper. Now, here's what I was talking about at the beginning of the lesson. It says it's less than it. If it's less than, you're going to use an open circle. If it was less than or equal to, you're going to use a closed circle. So at the origin, at 0, you're just going to have an open circle just like that. And you are done with that first part of the function. F of x equals x if x is less than 0. Now, piecewise functions, class, I mean, they're in different pieces. That's where the piece came from. So you have one piece of the function. Your other piece is this f of x equals 2. Or another way of saying it is y equals 2. So you're going to graph this line now. When y equals 2, that's a horizontal line, and it is at 2. So go up 2 and draw a horizontal line. There's your line. Now, class, we're going to have our restriction. Our restriction says we only want x when it's greater than or equal to 0. So we want x when it's 1, when it's 2, when it's 3, when it's 4, when it's 5, because those are all greater than 0. We don't want x when it's less than 0, -1, -2, -3, -4, so on and so forth. So you're going to get rid of everything that is less than 0 because you only want it when it's greater than 0. So these x's are all less than 0. You don't want those. You only want it when x is greater than or equal to 0. So as you can see, all of these green x's up here for my line, these are all greater than 0. Now when it says it's greater than or equal to, what you're going to have here is a closed circle. When it's just greater than or when it's just less than, it's an open circle. When it's greater than or equal to or less than or equal to, it is a closed circle. And there you have your piecewise function, class. It's two different lines, two different pieces to make a function. As you can see, the definition of a function is that it passes the vertical line test, and this one does indeed pass the vertical line test. It only touches the green or the red at one and only one point. All right, that might feel a little bit uncomfortable at first, but just like with anything in life, the more times you practice something, the better you get at it. So let's try number 3 now. H of x, class, it could be f of x, g of x, h of x. It doesn't matter. They're all just another name for y. So we're going to graph y equals 3, and we're going to graph y equals x plus 1. And then after we graph them, we're going to put our restrictions on at the end, and that, class, is where you're going to need your eraser. Make sure you have a good eraser for this lesson. So your first one, y equals 3. That is a horizontal line when y equals 3. So there is your horizontal line at 3. Now our restriction, it says x is less than a -1. So what's less than a -1? A -2 is less than it. A -3 is less than a -1. A -4 is less than a -1. So we want all of those. We do not want when x is greater than a -1. So if you look at your x of a -1, here is a -1 on the x coordinate right there. That spot is. You want everything less than it. So take out your eraser and just get rid of everything that is greater than a -1. So get rid of all this. You do not want all that. You only want up to a -1 on your x. And now look at, is it less than or is it less than and equal to? it is less than. Less than says you're going to use an open circle to denote that. So put an open circle right at a negative 1. That is your first half of the piecewise function. Your second half is y equals x plus 1. So in slope-intercept form, your y-intercept is a positive 1, and then your slope is 1. So you're going to go up 1 over 1, and you're going to continue this for as much graph paper as you are given. So you're going to go up and to the right, and then you're also going to go down and to the left. Left 1, down 1, left 1, down 1. And class, I want you to put in all of these individual points. It doesn't take too long, and then just connect the dots. So there is the line that represents the equation y equals x plus 1. Now notice the restriction. We're restricted to x being greater than 1. So you only want the x's that are greater than 1. This x is at 1, 2, 3, 4. Oh, this x is at 4 and 1, 2, 3, 4, 5. This x is at 4, 5. We want this point in our graph because my x is bigger than 1. This point right here is at negative 1, 2, 3, and at negative 2. We do not want this point because my x value is not greater than 1. So you want to get rid of all the x points that are less than 1. So here's where 1 is. You want to get rid of everything that's less than it. So take out your eraser and get rid of everything that is less than 1. Here is 1. And now, is it an open circle or is it a closed circle? You see that it's greater than 1, so you should have an open circle there. All right, there is number 3. We'll do number 4 together in class, and then I want you guys to pause the video and do number 5 on your own. So here's number 4, y equals x plus 2. So your y-intercept is a positive 2. And your slope is a rise of 1 and a run of 1. Up 1 over 1. And down 1, left 1. Draw your straight line. And then get ready to erase. Because you only want the x's that are less than a negative 2. This is true, x plus 2, if x is less than a negative 2. So go to a negative 2 on your x's. Negative 2 on my x's is right there. You want to get rid of everything that's greater than it because you only want x less than negative 2. So I'm going to take out my eraser and I'm going to get rid of all of that. And then it says x is less than or equal to. If it's less than or equal to, we use a solid line, a solid dot rather. There's half of your piecewise function. The other half is y equals 3x. Y equals mx plus b, so your b value is 0. So your y-intercept is 0, and your slope is 3, or 3 over 1. So it's a rise of 3, run of 1. A rise of 3, run of 1. Which is the same as going left 1, down 3. So from your origin, go left 1, down 3, left 1, down 3. You have successfully placed all the points that you can on your grid paper. Now connect it with a straight line. So you're all done except for that final restriction. That restriction is x is greater than a negative 2. So you're going to go to your x value of a negative 2. Your x value of a negative 2, here's the x of being a negative 2, so it's way down here on this red graph. And you only want everything that is greater than it. So you're going to get rid of everything less than it. So you're not going to erase very much on this one. This is the only part that we put on our graph that's less than a negative 2. And then you see x is greater than a negative 2, so it's not greater than or equal to, so it's not going to be a closed circle. It's going to be open. And there is the right answer for number 4. So you guys pause the video and try number 5 on your own. Number 5, h of x is another way of saying y. Y equals 4 minus x. Now class, this might have maybe tricked some of you. If we wanted to write this in y equals mx plus b form, the negative x would come first, and then the positive 4 would come second. So y equals mx plus b, y equals a negative 1x plus 4. Now this will be easier to graph. You're going to go to your y-intercept of 4, and then your slope is down 1 over 1. You always run to the right, so it's a rise of a negative 1 over a positive 1 to the right. Down 1 over 1, down 1 over 1. And you're going to continue this slope for as much graph paper as you're given. And there's your line. Let's put our restriction on there. Our restriction says we only want x when it's greater than 0. So when x is 0, which is right at this point, you want everything greater than that. So you do not want less than it. So erase what is less than it. And x is greater than 0, so that means it's going to be an open circle at that point. And then your other half of the piecewise function, y equals a negative 2x minus 2. You're going to go down 2 units. That's your y-intercept. And then your slope is down 2 over 1. Down 2 right 1. Remember, you always write these slopes as a fraction. Down 2 over 1. So continue this slope, which is the same thing as going left 1 up 2, left 1 up 2. And do this for as much graph paper as you're given. Then you're going to connect all those dots with a straight line. And we want it when x is less than 0. So when x is less than 0, here's the 0. So go to your graph at 0, which is right here. And you want to erase everything that's greater than it because you only want what is less than 0. So you're going to erase this right here. And if x is less than 0, you're going to want an open circle at that point. All right, class, and that's the lesson for today. So in just some summary, piecewise functions, you're going to graph a couple different parts or a couple different pieces. Graph the whole line, and then take your eraser and erase the restricted values. Once you have that, just remember if it's greater than or less than, it's an open circle. Greater than or equal to, less than or equal to, it is a closed circle. Be sure to ask me any questions if you have them on this lesson. Ask me tomorrow in class.